Hello y'all, this is 6.8 notes. We are back to standard form from our little trip over to vertex form last unit. And we are finding zeros today, and we are factoring when a is greater than 1. So what we are doing today is we're combining together 6.3, where we factored, set each factor equal to 0 when solved. We're combining that together, the setting each factor equal to 0 when solving part, with how we factored back in 5.9, so the very end of Unit 5. So a reminder of how we factored back in 5.9, and then we've obviously got examples, is that we would find two numbers that multiplied to AC and added together to B. We would split up the middle term of our quadratic using those two numbers, and then we would factor using grouping. So that means we factor the GCF out of the first two terms, we factor the GCF out of the last two terms, and then what's left behind should match. And we write our answer as those matching things that are left behind as one, and our GCF plus our GCF as the other. Okay, the only thing that's new about today is we're going to set each of those factors equal to 0, solve each of them equal to 0. Okay, so we have our magic X that we used back in 5.9. We're going to use that again today. And then we also have a really blurry version of our table telling us when we should use positive and negative numbers. First problem we've got here is 2x squared plus 17x plus 21. I'm going to draw my magic X. I need to find two numbers that multiply together to AC. So this is my A, B, C. So A times C is 2 times 21. So that means I need to multiply together to 42. And I need to add together to be 17. So if I need to multiply to be positive and add to be positive, I'm only going to be dealing with positive numbers here. The numbers that multiply together to be 42 and add together to be 17 are 3 and 14. And if you need to write out a factor tree to find those numbers, you obviously can. From here, we are going to split our 17x. We're splitting that up into 3x plus 14x. We're allowed to do that. We're essentially uncombining like terms. And then I've still got my 2x squared here. And I've still got my 21 here. So now I've got 4 terms, and I am ready to factor by grouping. So factoring by grouping, out of these first two terms, 2x squared and 3x, all I can pull out is an x. So 2x squared, pull out an x, leaves behind the 2x. 3x, pull out the x, leaves behind the 3. So I've got 2x plus 3 there. And out of 14x plus 21, I can divide both 14 and 21 by 7. So I can divide both those by 7. 14x divided by 7 is 2x. 21 divided by 7 is 3. Okay, and then the magic of factoring by grouping, this 2x plus 3, it's the same. So my factored form is going to be 2x plus 3. And then the other factor is going to be this x. Oh, that was an eraser, not a pen. My bad. This x and this 7. So x plus 7. So everything we just did is exactly what we did in 5.9. Now we have one more step. Well, actually, it's 2 more steps because we have to do it twice. We are going to take each of those factors and set them equal to 0 and solve. So we're going to take 2x plus 3, set it equal to 0. We're going to take x plus 7, set it equal to 0. 2x plus 3 equals 0. We subtract 3 from both sides. We get 2x equals negative 3. And then we divide by 2. And we'll get x equals negative 3 halves. And we are going to leave these as fractions. And you're going to get fractions today because these are problems that have a number in front of that a value, and the way they factor, you're always going to end up with a fraction for at least one of your answers. For x plus 7 equals 0, we can just subtract 7. And this one, we just get x equals negative 7. So that is all for that first problem. So everything's the same as 5.9, and then at the end, we just set each factor equal to 0 and solve, just like we did in 6.3. Okay, sorry, my dog's making funny noises. I don't know if that's picking up on the video. All right, one more problem. We are going to, I think there's one more problem. Yeah. We are going to do this problem again, but we are also going to do it with the quadratic formula. So there will always be two options. You can always factor, you can always use the quadratic formula. So we want to give you both those options, and we want to show you and then let you pick. So this one, we're going to start by factoring it like we just did. Then we'll do it again using the quadratic formula, and we're going to show you that you're going to get the same answers. So if we were to factor this, make my magic X, make it the same color I did on the last one. I think I did blue. So my magic X, I need to multiply to AC. So this is A, B, and C. That's the same A, B, and C we'll use for quadratic formula too. So 3 times 4 is 12. And I need to add together to be -8. So numbers that multiply to 12 and add to -8 are -2 and -6. So then I'm going to take my original problem, 3x squared minus 8x plus 4. I'm splitting this into -2x and -6x. This stays 3x squared. This stays plus 4. All right, factor this puppy by grouping. So out of these, sorry, I keep getting to the eraser accidentally. So out of these first two terms, I can again only pull out an x, leaves behind 3x minus 2. Out of -6x plus 4, I can divide both those by 2, and if that third term is negative, I always want to pull out a negative second GCF, so I'm going to pull out a -2. That's going to give me -6 divided by -2 is 3x, 4 divided by -2 is -2. So then my final factored form, 3x minus 2 times x minus 2. Okay, once I get those factored, I would set each of those equal to 0. So 3x minus 2 equals 0. I can add 2 to both sides and get 3x equals 2. Divide both sides by 3. I'm going to get x equals 2/3. My other one, I set x minus 2 equal to 0. I would just add 2 to both sides. Now we get x equals 2. Okay, so that is doing that using the factoring form. And I know I didn't go as slow that time. That's because now that you have a choice, you can choose which form you like better. So if you like factoring, if that's something you feel more comfortable with, go with factoring. If you feel more comfortable with the quadratic formula, use that. If you want to switch back and forth to practice both, you can do that. If you want to do it both ways to check yourself, you can do that. Or you can do it one way. If you get stuck, try the other. Lots of options. Okay, we're now going to do the exact same problem using the quadratic formula. So we've got our quadratic formula there. We're going to plug in a, b, and c. So x equals -b, so that's going to be -8. It's going to be +8. Plus or minus the square root, b squared, would be -8 squared minus 4 times my a value is 3 times my c value is 4. That's going to go all over 2a, which is going to be 2 times 3. All right, so now that I've got that all plugged in, I'm going to do my discriminant, so everything underneath the square root. So it's going to say 8 plus or minus the square root. -8 squared is +64. -4 times 3 is -12. -12 times 4, sorry about the dog barking, it's my neighbor. -12 times 4 is -48. 64 minus 48 is 16. And then 2 times 3 on the bottom is 6. So now I've got 8 plus or minus the square root of 16. So that's going to be 8 plus or minus 4 over 6. And then I can do my plus or minus. So I am going to do 8 plus 4 over 6. I'm also going to do 8 minus 4 over 6. So 8 plus 4 would be 12. 12 divided by 6 is 2. 8 minus 4 would be 4. 4 over 6 can reduce. I can divide the top and bottom of that by 2. 4 divided by 2 is 2.
6 divided by 2 is 3. So once again, I get the same answers of 2 and 2/3. So my answers are 2 and 2/3. I did that problem 2 different ways and got the same answer both ways. So for both your 6.8 assignment and your 6.9 assignment, when you're graphing from standard form, having an a value greater than 1, you can choose whether you use the quadratic formula, factor, sum of both, or do both on every problem. Completely up to you. Okay, that is a wrap for 6.8 notes.